So let's look at this example. Can you see the example, the blue screen? All right. Let me make sure the audio will be shared. Yes. So give me thumbs up when you hear what is being played, okay? I'm going to start playing in 3, 2, 1, now.
The derivative of the natural logarithm function ln x is 1 over x. Using the chain rule, the derivative of ln something will be 1 over the something times the derivative of the something. In part A, we find the derivative of ln 1 minus 3x. The function has the form ln something, so its derivative will be 1 over the something times the derivative of the something. The derivative of 1 minus 3x is minus 3. We can make the fraction look neater by multiplying both numerator and denominator by minus 1. In part B, we find the derivative using the product rule. The function is x cubed times ln x. So dy by dx is the derivative of x cubed times ln x plus x cubed times the derivative of ln x. We expand the brackets, then notice there is a common factor x squared, which we can take out.
Does that make sense? Okay, so let's see another one. Also, you need to remember the laws of log. It will come in handy. Okay? Remember that ln is logarithm. So if you have a product, you can split it. If you have quotients, you can split it also. If you have power, the power can be a a multiplier later. Does that make sense? Talk to me, guys. Okay. So we play this next, then we do some practice. I think I'll play all the log first, then the practice we continue. So everybody can go at their own pace. So I'll play this next. Give me thumbs up if you can see the screen and hear the audio, okay?
In this example, we find the derivative of some more complicated functions involving the logarithmic function. The laws of logarithms can help us to differentiate the logarithmic functions in this example more easily. In part A, we expand y using the law for the natural logarithm of a product. Now notice that the second term is a natural log of an exponential in base e. These are inverses, so ln e to the minus x is just minus x. We can now find the derivative term by term, remembering the derivative of ln x is 1 on x. In part B, we expand y using the logarithm law for a quotient. The first term is now the logarithm of a power, and the second term is the logarithm of a product. We use brackets to ensure that both terms in the expansion are subtracted. We can now find the derivative term by term. The first term is a constant times ln x, so its derivative is the constant over x. The remaining terms both have the form minus 1 times ln something. We start with the constant, then using the chain rule, we have 1 over the something times the derivative of the something. Again, we start with the constant, then using the chain rule, we have 1 over the something times the derivative of the something.
Does this make sense also? In this case,
in part A, we expand y
I want
using
to
the
explain
law for the
something
natural
here. I want to
logarithm
make
of
sure
a
everybody
product.
gets something here.
Now,
here, this is logarithm to base e of e to power minus x, right? So consequently, as a result of that, minus x can go to the back by the law of logarithm, right? And logarithm of e to base e is 1. So that is why the next thing that was written is simply, where is it?
X.
Can you see? That's why we have that. Okay? And to differentiate is easier. So when you have so-called complicated logarithmic function, you are advised to apply law of logarithm as far as possible, even before you differentiate. When you write, please be careful. Up to this step 3 is still y, not dy dx yet. Does it make sense? Dy dx only begins in the next step.
We can now find the derivative term by term.
See, dy dx only begins in step 4. Okay, so we need to be careful the way we write. And the derivative of this is 1 over 1. Derivative of this is just 1. Every rule of differentiation applies, and the special rules of log and exponential applies. Does that make sense? Okay, so that's that about that. Welcome, Nakita. How are you? Let's see.
Yeah, good.
Okay, so I will explain the example to you when others are practicing, okay, just in case you have questions. I didn't want to wait too long, but I will explain to you. Okay, so let's do some practice on this. Again, I'll send the picture of the example first. So just write derivative of logarithmic function as maybe the heading. Then practice in brackets, because today is about practice. So I will take a screenshot of this first and send to us in the group. Maybe I take a screenshot from the beginning. There's no need to write the investigation part. Just from here is okay. Okay, send to the group. If anybody needs to review that, then using the law of logarithm, also send. Then this example that we have just listened to, records. So after you are done, you don't need to merge them again. You are okay to leave it this way. So don't complicate things for yourself. So I will send 1 and 2 together so it can be bold and easily seen. All right, so I want you to begin with problems. Activity 1. Problems 1. Let's say from question 1, let's take the first 3, A, B, C. Begin with that. A, B, C. Then E, F. E, F. E, F, G, H. I want us to do as many as possible, okay? Then let's take the last 3 also, M and O. So I'll send that. What? Say that again?
Sorry.
Oh, okay, okay. I thought you were talking to me. It's all right. Don't worry, my Chinese is not strong yet, so I don't know what you're saying.
I was talking to my mom, sorry.
It's all right.
Yeah.
Okay, so let's look at question. Just continue with the first one, okay? Continue with the first one. If you don't want to send the problem 1 by 1, you can send 2, 2, or 3, 3 problems to me on WeChat. Yes, I'm checking your works. I want to see the screenshots